Dear student, now we will learn about all pair shortest path problem. The another name is called Floyd algorithm. So it is one of the application of dynamic programming algorithm. Okay. So in this algorithm problem, we are going to solve finding the shortest path from each vertex to all other vertex. That is Floyd algorithm or all pair shortest path problem. In Digitra, this algorithm is used to find the shortest path from one node to all other node. But in Floyd's algorithm or all pair shortest path algorithm, as the name itself, from all the node to all other node. Okay. So this is where the all pair shortest algorithm comes in handy. The most used all pair shortest path algorithm is Floyd algorithm. Now let's see how that algorithm is work. Okay. So as I said, no, the definition of Floyd's algorithm or all path shortest path algorithm is used to find all pair shortest problem from a given weighted graph. So here the input is graph. Graph means what? It contains number of vertices and edges. G equal to V comma E. Okay. From that all vertices to all other vertices. What is the shortest path? That is we are going to find the Floyd's algorithm. So finally, the result of this algorithm, it generates a matrix. Okay. This matrix will represent the minimum distance from any node to all other node in the graph. Okay. So this problem consists of finding the shortest between all pair of vertices in the graph. So by using dynamic programming approach, you can use this Floyd's algorithm. So I said, no, it is a graph. Graph means contains what? Vertices, n number of vertices, that is 1 to n. Okay. This vertices contains the subset is 1 to k. Suppose we have 3 number of vertices, so the k value equal to 1, 2, and 3. Okay. So for any pair of vertices, any vertex to any other vertices, we have to consider the path from that is 1 I to j, whose intermediate vertices all are drawn in between 1 to k, and b be the minimum weight path from the 1 to k. So this Floyd's algorithm, it exploits a link that is shortest path. We have to find the shortest path from I to j with all intermediate vertices between the I to j, that is 1 to k minus 1. So the link depends on whether or not k is in intermediate vertex of path. Okay. So now let's see that how to solve that all pair shortest path algorithm. So here, as I said, no, all pair shortest path algorithm means you have to find the shortest path. Where to find the shortest path? Between each and every pair of vertices in a directed graph G. Suppose this is the graph. So from this graph, this vertex to this vertex to this one to this one. Okay, what is the shortest path? Similar to this graph to this graph to this one, this vertex to this vertex. What is the shortest path? Similar to this node to this one, this one, this one. What is the shortest path? So we have to find every pair of vertices in a directed graph. So this solve pair shortest path problem is to be determined in a matrix format. Okay, that is matrix called A of I comma j. So the length of shortest path from that is I to j, that is we have to find. Okay, to solve this problem, there is a formula. Okay, the formula is that is a power k I comma j equal to minimum 1 less than or equal to k less than or equal to n a power k minus 1 of I comma k plus a power k minus 1 of k comma j comma c of I comma j. So this is the formula we are using to find the all pair shortest path from all the vertices. Okay, so here a power k I comma j means it represents the length of the shortest path from I to j going through no vertex of index, that index greater than k. Okay, but so please all of you remember this formula. Okay, so what is that? The formula is a power k of I comma j equal to minimum of from this value. Okay, this is one set and this is another one set. From these two set we have to find the minimum value. So minimum of 1 to n a power k minus 1 of I comma k plus a power k minus of k comma j comma c of I comma j. Okay, so before solving the problem, let know about that algorithm, how that algorithm is works. So we have to find the cost between that, that is the matrix A to that matrix contains n number of vertices. So that is 1 to n, and 1 to n means this is I value, it is j value. Okay, j value, it is the cost of adjacency matrix of the graph. Here the n vertices A of I comma j means it is the shortest path. I comma j means it is the shortest path from vertex I to all other vertex. Okay, so anyway, if you have a single vertex, then what is the cost? It is 0. So initially we have to assign the j dot cost of I comma I equal to 0 for 1 to n. Okay, then for I equal to 1 to n, do for j equal to 1 to n, do a of I equal to cost of I comma j. That is, we have to find the cost of I comma j, copy and paste into the say matrix A. Copy the cost of I comma j into matrix A. And for k equal to 1 to n, do for k equal I equal to 1 do n do and j equal to 1 to n do, and find the minimum cost. There is the same formula, a of I comma j equal to minimum of a of I comma j comma a of j comma k plus a of k comma j. This is the formula for finding the minimum cost. Okay, now let's see how this algorithm is works. With the example I will explain now. So here it is the graph. Okay, directed graph. So in this directed graph means what? There is a direction between each and every vertex to another vertex. So this weighted graph, we have to assign the weight for each and every vertex. Okay, so here 1 to 2, the cost is 6. Okay, 1 to 2 cost is 4, and 2 to 1 cost is 6. So the cost is the weight is assigned. Okay, we have to determine the length of shortest path between all pair of vertices in the graph. So we have to assume that this graph, there is no cycle with zero of negative cost. Okay, first we have to find the adjacency matrix. How to find the adjacency matrix? How many number of vertices? 1, 2, 3. 3 vertices. So you must write 1, 2, 3 row wise and column wise 1, 2, 3. Okay. Then have to find out 1 to 1. Initially 1 to 1. Is that 1 to 1? There is no cost for 1 to 1, so it is 0. Actually, this matrix is a 0 matrix. Here, all diagonals should be 0 only. Okay, because there is no self loop. Okay, 2 to 2, there is no loop, so it is 0. 3 to 3, no 0, no loop, so it is 0. So 1 to 1, 0. Next 1 to 2. So 1 to 2, what is the cost? 4. 4 you must write here. Next 1 to 3. 1 to 3, what is the cost? 11. 11 you must write. Next 2 to 1. So 2 to 1, what is the cost? 6. 6 you must write. Next 2 to 2, what is the cost? No loop, so it is 0. 2 to 3, cost is 2. Next 3 to 1. So 3 to 1, the cost is 3. 3. 3 to 2. 3 to 2, there is no direct edge between 2 to 3. It is 2 to 3, but we want 3 to 2, no direct edge. So if there is no direct edge weight assigned, then it is infinitive. Please remember this one. Okay. Next 3 to 3. 3 to 3, no self loop, it is 0. So this is the cost adjacency matrix. It is called A0 matrix. So how many vertex? 3 vertex. So we have to find k equal to 1, k equal to 2, k equal to 3. What is the cost? What is the shortest path? So we have to apply our general formula. So we already know the formula, that is minimum of 1 to n is a power k minus 1 of I comma k plus a power k minus 1 of k comma j comma c of I comma j. This is the formula. So we are going to apply this matrix in this formula. Okay, we have to find the shortest path. So to solve this problem, we are using different values k equal to 1, 2, 3. Why we are using up to 3? We have 3 vertex. Okay, number of vertices are 3. So we are using 3 values k equal to 1, 2, 3. Okay. So now let's see about this one. First, you apply k equal to 1. Okay, this is the formula. We already know the formula. Yes. So for that, you have to write one matrix, that is 1, 2, 3. 1, 2, 3. So first pair is a of 1, 1. Next pair is 1, 2. Next 1, 3. When k equal to 1, you have to find out this one. Okay, k equal to 1. What is 1 a of 1, 1? Apply this equation. Yeah, what is 1, 2? What is 1, 3? What is 2, 1, 2, 2, 2, 3? What is 3, 1, 3, 2, 3, 3? When k equal to 1. Similar to that is that matrix, this matrix called A1. Okay, already we have A0. So this is called A1 matrix. Similar to apply k equal to 2. Okay. K equal to 2. So the time the k values differ. So the time we have to find the cost A to 1, A to 2, A to 3. 2 to 1, 2 to 2, 2 to 3. C 3 to 1, 3 to 2, 3 to 3. and similar to k equal to 3. What is the cost for all the node? Okay, so if you are obtaining these three matrix, so when k equal to 2, that matrix output is A2. When k equal to 3, that matrix output is A3. So these three matrix A1, A2, A3, these are the shortest path from all the nodes. Okay, so let's see first one, how that first one is works. So here k equal to 1. Initially k equal to 1. So minimum of 1 minus 1, a power 1 minus 1, 0, comma, I is, it is 1, comma 1. So it is I value, this is j value. Okay, so here I is 1, k is 1, plus a power 1 minus 1, 0, a power 0 of k is 1, comma 1, and c of 1, comma 1. Okay, so where we have to collect these values? Okay, from that A0 matrix. So from the A0 matrix, this is the A0 matrix. For this graph, this is the A0 matrix. So 1, comma 1, what is the value? 1 to 1, the value is 0. So 0. A0, this is A0 matrix. 1, comma 1, what is the value? 0. Okay, and C of 1, comma 1. So here, this is the graph. So here 1 to 1, there is no loop. There is no loop. So it is 0. So minimum of 0, comma 0, what is minimum? 0 only. 0 plus 0, 0. So minimum of 0, comma 0, 0. So when we are finding 1 to 1, the value is 0. Okay, A1 matrix. Next, find 1 to 2. So 1 to 2. So applying this formula, A of A0 of 1, comma 1 plus A of, what is that? A power k, k minus 1, that is 1 minus 1, 0, because these all problems k equal to 1. Okay, 1, comma 2, C of 1, comma 2. C of I is now 1, j equal to 2. Okay, so A of 1, comma 1 from the A0 matrix, because it is A0. A0 matrix 1, comma 1 is 0. 1, comma 2 is, what is the cost? 1, comma 2 is 4. Okay, 0 plus 4. C of 1, comma 2. So from that given graph 1 to 2, what is that 1 to 2 value? 4. So that value we have to mention here, 4. So minimum of, you now 0 plus 4, 4, comma 4. So the minimum value is 4. You have to update here. Okay, next 1, comma 3. This is 1, this is 3. So 1, comma 3 obtained in the formula. 1, comma 1 is 0. Okay, 1, comma 3 is 11. So 0 plus 11, comma C of 1, comma 3. So this one you can get it from that graph 1, comma 3. So 1 to 3, what is the cost? 11. So 0 plus 11 is 11, comma 11. So minimum is 11 only. So you have to update in that A1 matrix. Now again k equal to 1, 2, comma 1, 2, comma 2, 2, comma 3. Okay. So here 2, comma 1, 2, comma 2, 2, comma 3. Applying this formula. So what is 2, comma 1? 2, comma 1 is 6. 1, comma 1 is 0. Comma 2, comma 1 from the graph. 2 to 1 is 6. 6. So 6, comma 6, minimum 6. So write 6 here. Next 2, comma 2. So 2, comma 2, there is no vertex. So for all 1, comma 1, 2, comma 2, and 3, comma 3 diagonal, it should be 0. Okay, so 0. And next one 2, comma 3. So applying this equation, and 2, comma 1 is what? 2, comma 1 is 6 plus 11, then is 17, comma 2. So which is the minimum? 2. So minimum cost you must do. So 2 comma 3 update in A1 matrix 2 comma 3 is 2. Okay, next step 3 comma 1, 3 comma 2, 3 comma 3. Okay. So here A1 of 3 comma 1, applying that equation. So 3 comma 1, what is that? Yeah, from A0 graph 3 comma 1 is 3. So 3 plus 1 comma 1 is 0, 3 plus 0, 3 comma C of 3 comma 1 from the equation 3 to 1 is 3. Okay, from the graph, so it is 3. So 3 comma 3 is 3. Next, A1 of 3 comma 2. Okay, so update 3 here and 3 comma 2 applying this formula 3 comma 1 is what? 3. Okay, and 1 comma 2 is 4. So 3 plus 4, 7 comma 3 comma 2. So from that, so for this you must observe from that graph. So 3 to 2 there is no direct edge, so it is infinity. So 7 comma infinity, which is minimum 7. So update 7, and we already know the diagonal matrix should be 0. Okay, so next, now what is the next step? For k equal to 1 we are founded A1 matrix. This is one result. Now we have to apply that step k equal to 2. Okay, k equal to 2 again from that same equation. So a square of 1, again new matrix 1 to 1. We have to find out again 1 to 2, 1 to 3, 3 2 to 1, 2 to 2, 2 to 3, 3 to 1, 3 to 2, 3 to 3. So minimum of a power 2 minus 1, k minus 1 comma I comma j. Okay, that is I comma k. I is 1, j is 1. So I comma k plus a k minus 1 of, that is k comma 1 comma c of I comma j 1 comma 1. Okay, so you have to obtain this equation. We already know that equation. The same equation we have to apply. Now it is a power k minus 1. So k is 2. Okay, k is 2. So 2 minus 1, 1. So a power 1 means A1 matrix. So previously when applying k equal to 1, we got the A1 matrix. Yes, this A1 matrix value you should apply here. So 1 comma 2. What is 1 comma 2? 4. So 4 plus, okay, 2 comma 1. So what is 2 comma 1? 6. 4 plus 6 comma, from the graph 1 to 1 there is no edge, 0. So 6 comma 4 plus 6, 10 comma 0. Okay, so that is you must write here. So minimum cost is 0. That is you must write here. Next 1 comma 2. Okay, applying the equation. So 4 plus 0 comma 4, the minimum cost is 4 right here. And 1 comma 3, the minimum cost, that is 4 plus 2, 6. And 2, 1 to 3 is 11. So 6 plus 6 comma 11, minimum is 6. You update here. Okay, that is A2 matrix. Already we are founded from A1. From that result, now we have to apply k equal to 2 and we take the value from A1 matrix and obtain the A2 matrix. Okay, now 1 to 1, 1 to 2, 1 to 3 completed. Next 2 to 1, 2 to 2, 2 to 3. 2 to 2 is always 0. The diagonal always should be 0. So here 6 comma 6 minimum is 6. Here 2 comma 2 minimum is 2. So update in that 602. Okay, and next 3 comma 1, 3 comma 2, 3 comma 3. So here also 7 plus 6. Okay, how to get 3 comma 2? So 3 comma 2 is So we are getting from that A1 matrix 3, 2 is 7. 7 plus 2 comma 1. 2 to 1 is 6. So 7 plus 6 comma 3 comma 1. 3 comma 1 means 3 to 1. What is that? Cost 3. So 3. Okay. So 13 comma 3 minimum is 3. That is you must update in that A2 matrix. A2 matrix. Next 0. Next this one 7 comma 7 minimum is 7. 7 here. And 3 comma 3 diagonal should be 0. A2 is completed. Okay. Already we got one answer A1. Now we got another one answer A2 matrix. Okay. Now similar to step 3, that is k equal to 3. Okay. K equal to 3. Again we have to construct 1 to 1, 1 to 2, 1 to 3. And 2 to 1, 2 to 2, 2 to 3. And 3 to 1, 3 to 2, 3 to 3. What is the value? You have to find the value from the equation, and the minimum value we have to write in the matrix. Okay. Now let's see. We got 3 different matrix values. That is A1 when k equal to 1, when k equal to 2, A2, when k equal to 3, we got another matrix A3. So these 3 matrices, these are all the sequence of decision and all final shortest path between all pair of vertices. Okay. So these are all the 3 that is the sequence of decisions from final shortest path between all pair of vertices. So that is Floyd's algorithm. Okay. So in Floyd's algorithm, how it is works? We have to initialize the n cross n matrix of distance. Okay. Then each edge u comma v, we have to update the matrix to be showing the weight of this edge. And for each edges, we update the weight. And we have to create the 3 nested loops iterations I comma j and k, and for every node we will find the distance to every other node. Okay, suppose the node I means I to j. We have to consider the k value as the intermediate point and update the distance if you find a less than the k value. Okay, so here we are founded all the vertices to all the other vertices. What is the shortest distance? Okay, but Digitro algorithm, this is different. This is a single source shortest path. Floyd algorithm is all pair shortest path. As the name itself, it is all pairs. All the vertices to all the other vertices. Digitra means one vertex to all other vertex. Okay, that means Floyd is n to n. Digitro algorithm 1 to n. One vertex to all other vertices. What is the shortest path? Floyd's algorithm is all the vertices to all the other vertices. What is the shortest path? Okay, so this is the way the algorithm is working. Okay, so please remember the equation. Okay, Now, if you remember this equation, from the equation only we are solving the minimum cost between one pair to all other pairs. Okay, when k equal to k is number of node. Okay, so in this matrix, how many number of nodes? 3 node. Okay, not 1, 2, 3. This is name. Okay, if you have 5 nodes, you have to apply k equal to 5 up to 5 nodes. Okay, that is 5 cross 5 matrix. You should be obtain and get the solution. 5 matrices: A1, A2, A3, A4, A5. 5 different solutions. These are all the possible solutions. Okay, from all the nodes to visit all the other nodes. Shortest to distance. We are finding the shortest distance, that is shortest path between all the vertices to all the vertices, other vertices. So the general formula is minimum of 1 less than or equal to k less than or equal to j. That is, you have to find the minimum from one set is, that is one set. So this is one set and this is another set. Okay, from these two set, you have to find the minimum value. Which one is minimum? Okay, so every time the k value, okay, it should be increased. It is depends on the number of nodes, 1, 2, 3 nodes. So k equal to 1. What is that matrix? Okay, find the minimum value. So when you are finding the value of c of I comma j, you have to find out from that given graph. Okay, if there is no edge between one node to one vertex to another vertex, you must define it is an infinitive. Okay, you must define as infinitive, direct edge. So 3 to 2, no direct. 3 to 1, 1 to 2 is there, but we need direct edge between 3 to 2. 3 to 2, there is no edge, direct edge. So you must always observe the arrow mark from where to where the values, that is the edges, are moving. Okay, here we have only 3 to 2, sorry, 2 to 3 only the cost is mentioned, not 3 to 2. So 3 to 2 is infinitive. So when you are finding the adjacency matrix, if it is perfect, okay, then only your problem all are remaining perfect. If your adjacency matrix, it may be somewhat mistakes, then your entire problem will be mistake. Okay, so I requested to all the students, please understand this problem. Okay, you have to work out and solve the problems and find out the cost of different matrix, shortest path from all the vertices to all the other vertices. Okay, so you must remember the formula first thing, and you have to find out the cost adjacency matrix. Okay, when you are finding the cost adjacency matrix, if there is no direct edge, you have to mention as a infinitive. You have to mention as infinitive. Okay, and the diagonal matrix, it always it may be a 0. So these are the diagonal matrix. Yes, you already know that. So these are the diagonal matrix. These are all, for this graph it is 0. Suppose here 2 to 2 the cost is 1 if it is mentioned, so then you have to write 1 here. Instead of 0 it is 1. Okay, so carefully observe the graph, directed graph, and write the cost adjacency matrix A naught. Initially it is A0, and remember this formula, how many number of vertices. 5 vertices means k equal to 1 to 5. Okay, 1 to 5. Here 3 vertices, 1, 2, 3 vertices, number of vertices. So up to 1. Okay. So each and every time when we are calculating the value of from the adjacency matrix for k equal to 1, we have to obtain from that A0 matrix. When k equal to 2, that is we have to obtain the values from A1 matrix. From A0 we are derived A1 matrix. From A1 we are derived A2 matrix. From A2 we are derived A3 matrix. Okay. And finally, all that 3 vertices A1, A2, A3. These are all the sequence of decisions. Okay. And all final shortest path between all pair of vertices. Okay. Thank you to all.